Hi, I'm Fargol. I'm the founder of Chemtastic, and today I'm going to show you some high school demos. The first one is set up here. It's the dry ice bubble, and the ingredients for that are glycerine and soap mixed together in water and dry ice. So we prepared a strip of paraffin to create the foam or the bubble on the surface of the bowl. Okay, so I'm going to start that now. Covering the soap mixture on the paraffin to make it ready. Put some soap around the bowl and put the water in. Get the dry ice bubble. Going to burst any moment now. Okay.
The second demo I'm going to show you is a fluorescence thermochromism demo, and for this we only need pyridine, copper iodide and liquid nitrogen. Pyridine is hazardous and this prac needs to be done in a fume hood. We need to mix about 50 milligrams or so of copper iodide with about 3 to 4 mils of pyridine until most of it dissolves in the pyridine.
Alright, so now that that's mixed, we're going to put it in the liquid nitrogen for a minute or two. At the moment it's not very fluorescent, but it's working sort of. I'll get the lamp up and ready so you can see now it's cool enough. There's some dry deposits on the side as well. You can see that yellow fluorescence from the dipyridine complex, the dipyridine copper iodide. What forms initially is the tripyridine complex, but that's not fluorescent. It's the dipyridine that is. And you can see it more clearly when you put it onto filter paper. So when we have the liquid pyridine copper complex again, we're going to add that to the filter paper, and we can see the colour changes much more clearly that way. So it's poured a bit onto this filter paper, and I'm going to put it into the liquid nitrogen and dip it in so you can see the yellow fluorescence is still there. You can see that's the copper pyridine, the tricopper pyridine complex itself is not fluorescent, but this is the dipyridine complex, and it's forming that bluish fluorescent color. So as it's evaporating at room temperature, we get that blue fluorescence. And you can see if we heat it up, it comes more quickly because the liquid is evaporating, and then we can get the blue fluorescence of the dipyridine complex. Okay, so now let's continue heating that and we'll see what happens. So when we heat that more, the dipyridine copper iodide complex loses one of its pyridines and it becomes a monopyridine copper iodide, and that's where the thermochromism comes into play, because the dipyridine, it doesn't have any thermochromism, it just stays blue when you dip it in the liquid nitrogen. So if we dip that in now, that blue colour is still going to stay the same, or whatever's remaining of it. But you see, surrounding the blue we have the monopyridine complex, which has the thermochromism. It changes colour. So we'll continue heating that so we can get all of the dipyridine converted to the monopyridine copper iodide, and then all of it will display thermochromism. So we've got rid of all the blue. We've just got the monopyridine complex, which turns purple when it's cooled down. And the main reason for that is that the liquid nitrogen cools it down enough so it slows down the transition states, and with less vibrations we can actually see the fluorescence. When it's heating up, it goes a bit orange, red, and then all the purple goes away. This is the end of the demo. If you enjoyed it, you can subscribe to our online videos, and they have more detailed chemistry explanations. You can also participate in one of our exciting workshops at your school by booking a session with me. I look forward to doing some fun chemistry experiments with you, because science is a lot of fun. Thanks for watching.